Okay, worksheet number 1, question number 7 and 8 here today. Number 7 says a 1 kilogram rock is thrown up into the air, ground level, speed of 8 meters per second, travels up, returns down to the ground. What's the momentum when it strikes the ground? Logic can tell us in this question that the final speed of this rock is 8 meters per second down, right? It starts at 8, it slows down, stops when it reaches the peak height, and then it comes back down, speeds up at the same rate as it slowed down at, and reaches the same speed. In the absence of that logic, and some people don't have that right away, in the absence of that logic, we just say VF squared is equal to VI squared plus 2AD, and we solve for VF. We would say VF is the square root of VI is 8. A is neg 9.81. What's the displacement if we're looking at this entire trip from start to finish? 0. So we'd say 2 times 9.81 times 0. They cross that out. Square root of 8 squared is, lo and behold, it's 8, right? We speed up. If we slow down at 9.81 and then we speed up at 9.81, we're going to be going the same speed as we started. So it's 8.0 meters per second. What did we just solve for? Quick, what did we just solve for? Final? Nope. Speed. Final speed, right? Final speed is 8. What's the final velocity? Right, or negative 8 meters per second. So let's find the final momentum now by saying m times v. Mass is 1.00 kilograms times negative 8.00 meters per second, which gives us, of course, negative 8.00 kilograms meters per second. Or some people say down instead of the negative. That's fine. Doesn't matter. Just don't say both. Good? Now, when you look at question number 8, boy, it reminds me a lot of question number 7. It's almost the same. It's certainly the same situation. Question number 7 and in question number 8, we have a rock that's thrown up into the air from ground level, comes back down to ground level. What's the momentum when it hits the ground? It's the same context of question entirely, which means the equation that we just tried and it worked, we can try again if we want. For number 8, we could absolutely say VF squared is equal to VI squared plus 2AD. What would A be in question number 8? Dylan, what would A be in question number 8? The acceleration as it goes up and comes back down. Yeah, same as it was in number 7, right? Neg 9.81. What would the displacement be? 0. So this would disappear. What would VI be? What would VF be? We don't know. So the worst case scenario has just materialized. And the worst case scenario was really not that bad of a scenario at all. We tried something that's valid, and what happened? It didn't work. It wasn't wrong. No, it wasn't wrong. There's nothing wrong with what we just tried. It just didn't work. Okay, it is perfectly valid. If it's valid for question number 7, it's valid for question number 8. Doesn't mean it's going to work for question number 8, but it's valid. We tried it, it didn't work. So what do? Try something else. Listen, we might try, this one's not going to work for us. Maybe we try A is equal to delta V over delta T. Guess what's going to happen if we try A is equal to delta V over delta T? Our worst case scenario. It doesn't work. We're not going to get a wrong answer. We're just going to get a couple of unknowns, and it's not going to work for us. You got a question?
I used the first one.
You used the first one, and you got
I
it.
think I made an assumption.
What'd you do?
Yeah, it was 0.
Okay. So what did you say D was? 7?
No.
What did you say D was? 0?
You say
D.
D? Oh, I thought it was
Okay, you said 7?
But there's no displacement.
Yeah, so you've actually made a couple mistakes in there, and 2 mistakes kind of made a wrong, or 2 wrongs kind of made a right there. Yeah, yeah. But you made 2 mistakes that kind of canceled each other out there.
So since I was looking at how it said as it strikes the ground.
Yeah, yeah. But when something strikes the ground, it's moving, right? If I was to, here, let me do a little demonstration for you. That doesn't work, so we could try another equation here. D is equal to VIT plus 1/2 AT squared. D is equal to VFT minus 1/2 AT squared. Listen, none of them are going to work. They're all valid. They're all valid. but we end up getting a couple unknowns with each one, so they don't work. This is when we have to think outside the box a little bit. We keep trying something that's valid, not working. So we got to rethink this question. Like, rethink this question back to the beginning. Instead of analyzing the whole trip, why don't we analyze just the trip down? Why don't we analyze part of it? We could analyze just the trip up too, right? But since we're looking for the momentum as it strikes the ground, probably the trip down makes the most sense. So we're rethinking this question right from the beginning. We started doing valid things, none of them worked, that's okay. We rethink the question from the beginning and say, I'm not going to analyze the whole thing, I'm going to analyze just the trip down. And for that, I could say VF squared is equal to VI squared plus 2AD. And for that, VI would be 0, because it stops there momentarily and then starts moving when it comes back down. So this disappears 0. Square root of 2 times negative 9.81 times technically negative 7. And that gives me a final speed here of 11.71921. And then we say P is equal to M times V. What's my velocity? 11.7? Close. What's my velocity? Yeah, say 11.7 down or negative 11.7, right? Oh, and that gives us negative 17.6. So I like this question on a number of fronts. And I say that I'm not trying to give you a hint as to like, oh, this is a test question or whatever. I'm just saying I like it on a number of fronts because it's just a good question. But it also demonstrates for us one of the most important things that most important strategies that we can take all through Physics 30, and that is don't be afraid to try. Don't be afraid to try. Okay? We tried VF analyzing the whole trip. We tried analyzing it like we did question number 7. Didn't work. We tried a different equation. Didn't work. We tried a different one. Didn't work. Then we rethink the question from the start. Hey, it worked. Don't be afraid to try. So worst case scenario if you try? Well, if you try something valid, like worst case scenario is you try again. Even if you try something invalid, the worst case scenario is you get a wrong answer. It beats not getting an answer. Right? It beats not doing it. Don't be afraid to try. Don't be afraid to be wrong. Okay, when you're not afraid to be wrong, you're probably going to be right more often than not. I'm going to do another example now. The last example for this topic number 12, momentum, says the momentum of an object is 200. Whatever direction, positive direction. What does the momentum become if the mass is doubled, but the velocity of the object is reduced to 1/3 of its original value? I don't know about you, but when I see this question, right away I'm starting to think, wow, if I'm solving for momentum, I'm going to say P is equal to M times V, right? That's the first thought that comes to my mind. Don't worry about whether it's going to work or not. That's the first thought that comes to my mind, probably yours too. Looking for momentum, P equals M times V. What's the problem with that here, though? What's the problem? What's M? What's V? Do you know? No. We're changing M and V. We don't even know what it was, right? We're changing the value of these variables without even knowing what they were to begin with. I call the technique that we're going to use to solve this question variable value changing. We're changing the value of variables without knowing what they were to begin with. And this is something that applies not only to momentum, but all throughout the course. We could do this same technique with any equation that we learned this year. It's just the first time we see it is with this equation, that's all. Here's what I want you to do. Write down the equation, okay? Even though you don't know what M is, you don't know what V is, write down the equation. Do it anyways, because you know you're going to have to do that, use that somehow. And then I want you to put a little subscript beside the P. What do you think that O stands for? What is it? Original. Yes, that's my original momentum. Now, I'm going to let you in on a little secret. Don't tell anybody. When I told you on Thursday and on Friday and earlier today that the equation for momentum is m times v, I lied. The equation for momentum is not m times v. The equation for momentum is mass times velocity. We simply represent mass times velocity as m times v. We could have called velocity q, and then we would represent mass times velocity as m times q. Does that make sense? M times v is the accepted way to represent it. That's the way we'll nearly always represent it. But it could be something else. We just choose the common way of m times v. So, if my original momentum is m times v, and by the way, it's also 200, right? If my original momentum is mass times velocity, represented by m times v, my new momentum, n stands for new, my new momentum is also at mass times velocity. We're just not going to represent mass by m. What do you want to represent the new mass by? Not m. Yeah, 2m. Right? It's twice what it was. So if we represented it by m, now we're going to represent it by 2m. Now understand, like, it's still mass. We're not saying the equation is now 2 mass. It's not. The equation is mass times velocity. But the mass is represented by 2m now, instead of by m. And what do you think we're going to represent the velocity by? Still velocity, but it's, yeah, v over 3 or 1/3 v. Doesn't really matter which, right? I would say, though, stick with the fractions. 1/3 or v over 3 doesn't really matter, but don't say 0.33. It's easier with the fractions here. Now, let's simplify this a little bit. Combine the 2 and the 1/3, pull them out front. We get 2/3 m times v. Look at this. Look at what just happened. Here's m times v. Here's m times v equals 200. Well, if my new momentum is 2/3 m times v, and m times v is 200, then why don't I just say my new momentum is 2/3 times 200? That make sense? What's 2/3 times 200? Yep. Yep. We'll just round it to 3 digits here. 133 kilograms meters per second. It's almost like magic. I just figured out what a momentum is without knowing what m is, without knowing what mass was, and without knowing what velocity was. Just by changing the variables, right? So the strategy is just twofold, 2 steps. 1, write down what you got. On my data sheet, I have an equation. In the question, I have 200. Write down what you got. Step 2, write down what it becomes. Write down what you got. Write down what it becomes. And then I end up with the answer. Let's have a look at this practice question that I've written on the board here. It's going to use the same technique as we just used. This time, though, we're saying the velocity of the car is 20 meters per second. This is what the velocity is. But what does the velocity become if I cut the momentum in half and I reduce the mass to 2/3 of what it was before? All right, everyone, now that you've had a chance to work on it, I see lots of people have the right answer here. My equation is v is equal to p over m, right? It's p is equal to m times v, but I got to rearrange it because I'm trying to see what happens to v, not to p. Put a little o beside that, my original velocity, and put a 20 beside that because my original velocity is 20. It's also p over m, but it's equal to 20. Now let's make my changes. I've just written down what I've got, right? My equation and the number. Let's make my changes. My new velocity, what's p? Or sorry, what's momentum, I should say. P is p. What's momentum? What's momentum? What is it now? Was p, now it's half, right? It cut the momentum in half. It's 1/2 p. And mass is, well, it was m. Now it's 2/3 m, right? And I'm going to divide those two fractions. Some of you guys call it kiss and flip. Some of you guys call it multiply by the reciprocal. Same thing as saying 1/2 times 3/2. 1 times 3 is 3. 2 times 2 is 4. So this is what it becomes. Oh, but wait, p over m is 20. So we're just saying 3/4 times 20 is equal to 15. How many people got that? Good. Make sense? All right.